Coming up next on Jonathan Bird's Blue World, Jonathan goes to inner space at NASA's Neutral Buoyancy Lab, where astronauts are trained.
You gotta tell me what it's like to be in space.
What's it like to be in space? Well, it's a lot like being in the pool here. The only difference is when you turn upside down in the pool, you feel upside down. When you turn upside down in space, there is no upside down, so you don't feel that, have that sensation of blood rushing to your head, and you can't beat the view.
And what comes after the International Space Station once its mission is over? How do we ensure the presence of humans in space?
Well, that's a great question. The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
And I'm standing on the International Space Station.
Standing on an underwater full-size replica of the International Space Station in a gigantic indoor swimming pool.
How do we know the Earth is not flat?
We don't. It's
I
flat.
descend into the clearest water I've ever seen, and it looks like an underwater movie set. The pool is a staggering 40 feet deep, and everywhere I look are full-size replica sections of the International Space Station. I take a few minutes to explore the pool. I can see from one end to the other very clearly, meaning that the underwater visibility is over 200 feet. Here, they train astronauts to work in zero gravity by simulating these conditions underwater.
Technologies that we're testing out on Space Station are definitely helping us with our goals of going beyond low Earth orbit.
Okay, hold still now. This is for Obamacare, Guantanamo Bay, the Patriot Act, and that damn ugly dude you married.
How do you recycle the oxygen? It's the main crucible test bed where we've been trying to grind out all the lessons that will eventually let us go to the moon, that will eventually let us go to the moon.
Astronauts to the moon.
Well, that's a great question. The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
Any ill effects from the Van Allen radiation belts?
No. Now, I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
The space shuttle went to 365 miles a few years ago because I worked in news. I saw CNN. They said that the radiation belts surrounding Earth are more dangerous than previously believed because the astronauts saw shooting stars with their eyes closed when they got within 600.
Radiation belt. We saw shooting stars, but they're not shooting stars with your eyes closed, although they look like it. If you're out in space beyond the Van Allen belt, and probably within the Van Allen belt, and close your eyes, and just pay attention. You don't notice it unless you pay attention. Then all of a sudden you'll see a little flash like a shooting star, except it's like that. There goes one this way. Then one just blossoms. And then not that fast. Maybe you wait 3 minutes or 2 minutes and one goes whoosh. And what's happening is cosmic rays are hitting the back of your eye and exciting those sensors in the back of your eye. So that's what you see. And they got high enough apparently to close them. My guess is in Earth orbit, if you closed your eyes and just paid attention, that you would see them.
The first time they were seen was when they went to 365 miles.
Yes.
That's 650 miles below or away from the radiation.
Yeah, see, it's below. My guess if they just did it tonight. But see, if you're just going to sleep or closing your eyes or it's dark, you don't notice them. But if you'll close your eyes and pay attention, which we had an experiment to do, by the way, then you see them whistling by. Not on our mission, by the way, they hadn't been discovered yet. I saw them one day on the moon. It wasn't dark, and it was kind of dark, and I saw this flash of light, and it looked like it was on the moon, but really it wasn't. It was a flash of light.
technologies that we're testing out on space station are definitely helping us with our goals of going beyond low Earth orbit. So we have a really robust exploration program at NASA.
Previous program, we are setting a course with specific and achievable milestones. Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
So how did we send humans to the moon 6 times so early on, but we can't figure it out in 2016? How was it so easy to go to the moon in 1969 using this flimsy lunar module?
Space may be the final frontier, but it's made in a Hollywood basement.
What? Where'd he go? Shit, shit, shit.